Let's solve this question. This is another standard question, very simple. Suppose that the statement is false. Suppose that this statement is false. Find all the combination of truth values of r, s for which this statement will be true. So the question is saying that this statement is false. This statement is false. What this tells you? What this means? Let me know. If this statement is false, what that means? This statement will be false only when P is true and this right hand side. See, this is LHS. You can call it this is RHS. So this will be false. This statement will be false only when this is true, this is false. So I can say that when Q bar is false, that is same as basically P true and Q true. This information is given to you, P true, Q true. Okay, now we have to find when this will be true. All combination of truth values of r, s. All combination of truth values of, so this is given like P, Q. These are true, that is given to you. Okay, now the question is asking this negation Q implies R and negation P or S. So if this is true, then what can you say about R, S? Then what can you, from this, what can you say about R, S? The question is asking for R, S. Remember, the question is only asking for R, S. So if this is true, so P, Q are already true. Now just put it. P is true, Q is true, so that is false. So you can, it's like this. False implies R and false or S. This complete thing is true. Okay, this complete thing is true. Now false implies R, that is true, right? False implies R, that is true. False implies anything is true, we already know. So I can say that false implies anything. This is true. Now what about this? False or S, that is S. You know, false or anything, false or alpha, that is alpha. We have already seen this in the last live session. Okay, so this is S. So finally what you have, what about true and S? What about true and alpha? That is alpha. All these things we have already seen in the last live session. These points, the last live session, covered in last live session, you can check. Okay, so now you can notice that finally true and S, that will be S. So finally S will be true. Okay, so S must be true. What about R? R can be true or false, right? S must be true, but R can be true or false. S must be true. So R can be either true or R can be false. So finally, how many I can say combinations are possible? So your answer will be what? So your final answer will be only two combinations, S, R. Either this should be, I can say something like this, or this should be something like this. So the answer will be only two combinations. This is the answer, only two combination. Okay, simple. So this is a, you can easily see this is a simple question, that suppose that this statement is false. So you know that from this statement is false, means P is true, Q is true. Now this statement is true, then you have to find combination of R, S. You have to find the combination of truth value of R, S. So this will be the answer. Okay, let's move on. What about this one? Let's see this question. Find all the combinations of truth values of PQR for which this statement is true. Will you create the truth table for this? Are you going to create truth table for this? This is a dumb method. See, if you create a truth table, like you are creating a truth table PQR, it will take a lot of time. You will create total 8 combinations, total 8 rows will be there. Then you will calculate this expression. This expression you are going to calculate for each. For each you are going to calculate. So this is going to take a lot of time. This truth table, this is a dumb method. This is inefficient. Whenever, if you are solving truth table, if you are using truth table, this is inefficient. Let's use some analysis. Let's do some analysis. Okay. The question is saying that this is true. The question is saying that P double implication okay. The question is saying that this is true. So now, can you tell me how many cases are possible? See, only 2 cases are possible, right? Either P will be true or P will be false. Please understand. From P point of view, from P's point of view, how many cases are possible? You can pick any of them. P, Q, R, any of them you can pick. Okay, any of them. You can pick any of them. Only 2 cases are possible. See, either P will be false or P will be true. Either P will be true or P will be false. Correct? From P point of view, from P's point of view, either P will be true or P will be false. And the same thing you do in the truth table also. In the truth table, actually, what you do, if you have, for example, if you are creating a truth table, and let's assume you have 3 variable P, Q, R, then what you do, actually, the same thing you do in the truth table. You know that either P is true or P is false. Okay, P is true or P is false. So, for example, you can notice in here P is false. Okay, and here P is true. So you can notice that either P will be false or P will be true. Now here you can make combinations of Q, R. Here you can make combinations of Q, R. Okay, so can I say that only 2 combinations are possible? Only 2 possibilities are there. Only 2 cases possible. Either P will be true or P will be false. Same thing you can say for Q. The same thing you can say for Q. Either Q will be false, Q will be true. Okay. The same thing you can say for R. Either R will be true, R will be false. So only 2 cases are possible. I can say either P will be true, or what is case 2? P is a false. Either P will be true or P will be false. This case, it is covering how many rows of truth table? This case, when P is true, this case is covering how many rows of the truth table? How many rows of the truth table are covered here? In this case, how many rows are we considering? Total 4 rows. Because you can easily see, when P is true, then total 4 rows are there. We are considering all the combinations of Q, R. Okay, we are considering all the combinations of Q, R. So please understand that in this case 1, we are considering 4 rows of the truth table. So if P is true, then this is false, right? Okay, the entire thing is already true. The question is saying that entire thing is true. Entire thing is true. P is true, so this will be false. So what should be this value? So what should be this? This will be false. This should be false, right? Because if P is true, then this is going to be false. This is going to be false. And there is a by implication. This is going to be false. It's like false by implication alpha. When it can be true, this alpha must be false. This alpha must be false. So the same thing I am saying, that this alpha, this is your alpha, let's call it. So this alpha must be false. So I can say Q and what is this? You can do this. P is true. In this case, P is true. What about true implies R? What about that? In the last lecture, we have seen this. That is R. Okay. True implies R, that is R. We have already seen this. So true implies R, that is R. In last lecture, we have already seen. So you can notice this will be r dash. This is false. Okay, now you can easily see three possibilities, correct? Okay, so from here you got answer. Okay, three combinations are there. Sorry, yeah, this is false. This is false. So three combinations are there, correct? This is your conjunction. Conjunction is false. So three combinations are there, correct? Q conjunction R bar is false. So there are three combinations. So ultimately, in this case, one you got three combination. Okay. So finally, you got three combination. The question is asking how many combinations are there. You already got which combinations you got. So you can notice that these combination you got. P true is fixed. P true is fixed, but you got these combination. Okay. So you can see these combination we got that P Q R. P true is fixed. Okay. We got true false, false true, false false. So these three combinations will make this statement true. Okay. Similarly, you can do case 2. In case 2, what you are doing? P is false. Okay. If P is false, then this will be true. True by implication alpha is true. What is alpha? What should be alpha? Alpha should be true. So this alpha, this should be true. Okay. And remember, P is true. P is true. So what is? So you can notice. Sorry, P is false. P is false. So what is false implies R? What is false implies R? That is true. False implies R. That is true. Okay. So you can easily see from here what will happen. That this must be true. Q, this complete thing is true. So this alpha, let's call it alpha. So this alpha must be true. So I can say Q and this is okay. So you can see this is true. Okay. So this is contradiction. That false must be true. False must be true. That is contradiction. False is equal to true. That is contradiction. Means no possibility. So from this case, we are getting no possibility. Your final answer is what? Your final answer will be what? That will be 3. Your final answer will be 3 possibilities. Are the 3 possible combinations. Here actually the 3 possible combinations are these: false, 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 true, true, true. Oh, these are the possible combinations. Okay. So these are the possible, because this is R bar. This is Q and R bar. This is Q and R bar. Okay. So your answer will be, so you can see this is Q and R bar. Okay. FF, FT, TT. FF, FT, TT. So this is your answer. Please tell me, did you understand? This is a simple question. I am simply saying that only 2 cases are possible. See, if you take any propositional variable, that is either true or false. Okay. So if you have any propositional variable, for that propositional variable, whether you take P or Q or R, that is your choice. Okay. Any propositional variable you take, then there are 2 cases. Then there are 2 possibilities. Either that propositional variable will be true or it will be false. Only two cases are there. Okay. So very simple. So here I am taking P. Either P is true, that is case 1, or P is false, that is case 2. So only 2 cases are there. Okay. Abhay is saying that this question is lengthy question. No, this is not a lengthy question. Actually, because I am explaining, so it is taking time. But if you solve this question by yourself, once you do enough practice, okay, once you solve 5 or 10 questions similar to this, then this question is very simple actually. Okay. And let me tell you, after few months, after maybe 1, 2 or 3 months, this type of questions will look very easy. It is possible that you will not even spend 30 seconds on this type of questions. Okay. Now let's see this interesting question. This is another question from the standard book. Okay, let's see this. Okay, the question is saying that, so basically you are discovering an old paper in graph theory that is discussing some viscosity, I don't care, viscosity of graph that is made up by an author. The author is saying that this is made up by me. Okay, so a theorem in this paper claims that there is a theorem, and the theorem says that if a graph satisfies condition V, then graph is viscous. Okay, then graph is viscous. Which of the following are equivalent ways of stating this claim? Tell me what is the claim? Tell me what is the claim? What is the theorem? What is the theorem? That if someone satisfies condition V, then the graph is viscous, right? If condition V is satisfied, then the graph is viscous. This is given, right? Agree or not? See, the theorem, the question is saying that theorem is given to you. What is the theorem? This theorem says that if a graph satisfies condition V, then graph is viscous. Means if this condition V is satisfied, then graph is viscous. This is some condition. I don't know what is this condition. Okay, then this graph is viscous. Okay, then the graph is viscous. Now, so what can you say about from this? So I can say if condition V satisfied, then graph is viscous. Can I say this V, is this sufficient or necessary for graph to be viscous? This V, this condition, is it necessary or sufficient for graph to be viscous? This is sufficient, right? So I can say this condition V is sufficient for graph to be viscous. So here I can say that condition V is sufficient. Okay, so it is sufficient to satisfy condition. So this statement D is correct. Yes or no? Statement D is correct, because the question, you can easily see that here, from here I can say that this condition V is sufficient. Okay, this statement I can say like this, that condition V is sufficient. V is sufficient for graph to be viscous. I can also say like this. I can also say like this, that who is necessary? Okay, graph viscous is necessary, right? Graph viscous is necessary. Okay, graph viscous is necessary for condition V. Okay, for condition V. So graph viscous is necessary for satisfying condition V. For satisfying condition V. Okay, isn't it? Right? So you can see condition V is sufficient for graph viscous. I can also say graph viscous is necessary for satisfying condition V. I can also say viscous only if graph, I can also say condition V only if graph viscous, right? I can also say condition V only if graph viscous. Okay, so very simple. These things are very simple. Now, finally, I can say that for graph to be viscous, it is sufficient. Condition V is sufficient. So this is correct. Condition V is necessary. This is not correct. Okay. Now, next, graph is viscous only if it satisfies condition V. That is not correct. Yes or no? Because only if means this direction. Okay. Only if means this. So this statement A is also not correct. If this means this, yeah, this is correct. Option B is correct. So B comma D are correct. Yes or no? For this question, B comma D, these are correct. Simple question actually. Anyone has any doubt? And what about these two? These four more statement. Satisfying condition V is sufficient for graph to be viscous. Yes, that's correct. Satisfying condition is necessary. That's not correct. Every viscous graph satisfies condition V. every viscous graph, this is basically like graph viscous implies satisfying condition V. This is not correct. Only viscous graph satisfies condition V. Only viscous graph satisfies condition V. Means if you are satisfying condition V, then your graph is viscous. This is correct. See, please understand the difference between these two statements. What statement G is saying? See, let me give you two statements. Every natural is integer. Is this correct statement? From your knowledge, is this correct statement? Every natural is integer. Yes, this statement is correct, right? But this actually basically what says? Who implies whom? This statement basically says that if it is natural, it is integer, right? If it is natural, it is integer. Now, if I say only men are in army, okay, let's assume if I say only men are in army, okay, now what it means? Tell me what it means. Does it mean if you are man, then you are in army? Or does it mean if you are in army, then you are man? What it means? Please tell me. Let me know. Let me know. Let me know. See, I am saying only men are in army. Only men are in army. Does it mean man implies army? If you are man, then you are in army? No, it implies that if you are in army, then you are man. If you are in army, then you are man. So the same thing is happening here. Every viscous graph is satisfying, every viscous graph satisfies condition V. Every viscous graph satisfies condition V. That means GV implies V. And only viscous graph satisfies condition V. This means if you satisfy condition V, then you are viscous. If you satisfy this condition V, then you are viscous. So this is correct. H is correct. G is not correct. So this was another question. Please tell me. A simple question, but a good question, right? Easily people can make mistake in this question. It is, I can say this question is like error prone. Okay. Very easily people can make mistake. Which point? Swapnil, please tell me. Okay. Please repeat option A once. Option A. See, this we have already seen that. Tell me what this means. P only if Q. How do we write this? How do we write this? P only if Q. How do we convert this into propositional logic? In propositional logic, how do we convert? I told you P only if Q. That what it means? It basically means P implies Q. This we have seen many times actually. This actually we have seen many times. Okay, P only if Q. So we write like this. P implies Q. Do you know why? Okay, all the students, do you understand why I told you, right? In the lectures, I have see every point I have told you. The proof of every point I told you. Okay, because here Q is necessary. Very good, very good, very good. Brilliant. See, P only if Q. It simply means P only if Q. P happens only if Q happens. Who is necessary? P happens only if Q happens. I will go to party only if my friend goes to party. So my friend is necessary. So this is basically like Q is necessary for P. I will go to party only if my friend goes to party. So here basically friend is necessary for me to go to party. Okay, so Q is necessary for P. That is same as P is sufficient for Q. That is same as P implies Q. So this is your P implies Q. Now your option, now you can notice, now what is your option? This option A. This option A basically says that if graph is viscous, then it satisfies condition V. That is wrong, right? That is wrong because what theorem is saying? This is what theorem is saying. See, Saurabh, the theorem is saying this. See, Saurabh, this theorem is saying that if you satisfy condition V, then graph is viscous. The theorem is not saying the other direction. Okay, we don't know. The other direction, we don't know. There is an old paper, there is an old research paper in which you find this theorem. You don't know whether the another direction is correct or not. We don't know. This theorem is this paper is saying that if graph satisfies condition V, if you satisfy condition V, then graph is viscous. We don't know. This we cannot say. This we cannot say. Okay. This we cannot say. So please understand that we cannot say this. Basically, this theorem is this. Theorem says that if you satisfy condition V, if a graph satisfy condition V, then graph is viscous. Okay. Please understand that if graph is viscous, then it will satisfy condition V. We cannot say. We don't know. May or may not be true. So this we can't determine. This may or may not be true. Okay. Yes, if it is by implication, then you can say. If it is by implication, then this will imply this will imply this. Okay. So this question is this done? Should I move on to the next question? See, these standard questions are beautiful, right? Very small mistake. Of course, many students can make mistakes in these type of questions. Okay. Now let's move on. Let's see this one. The final question. Okay. So let's see this. This is another question actually. Let me tell you, there is a book. It is real. Okay. So there is a book on Google. You can find it. What is the name of the author? So there is a person. This is Ismulan. Okay. So if you Google it, there is an author, Ismulan. Okay. There is a book and there is a puzzle book. In this puzzle book, the name, let me tell you, the name of this puzzle book is, what is the name of this book? This is the name of this book. Okay. What is the name of this book? This is the name of this book. That what is the name of this book? Okay. Are you getting my point? See, this is a book of puzzles. And these puzzles are not dumb puzzles. Okay. These are not dumb puzzles. Like these are not do aksar ka mera naam ulta sulta x. Okay. This is not like that. These are not your newspaper puzzles. No. Okay. This is a puzzle book, but the puzzles are not your newspaper puzzles. Okay. These are not, I can say, 3-year-old, 4-year-old puzzles. These are not that. Okay. These are good mathematical puzzles. Let me tell you. Literally, these are mathematical puzzles. Mostly logical. So basically, these puzzles you can easily solve if you are very good at logic. If you are very good at mathematical logic. Okay, mathematical logic. If you are very good at mathematical logic, then you can solve. Is this clear? So these are not those dumb puzzles, you know. Okay, is this clear? So 4 line will be there. Okay, मैं ये हूँ, मैं वो हूँ, बताओ मैं कौन हूँ. Okay, so it's not like that. It is not like that. Okay, so it is basically, this is a good book. Actually, let me tell you one story. When I was preparing for the GATE exam, then I got to know about this book. Okay, and there is a friend of mine, Lokender. So he and I, we downloaded this book. You can find this book on internet. Okay, what is the name of this book? You can find this on internet. You can download this, and in this book we used to solve these puzzles. Okay, of course we did not solve much. I think hardly 10 puzzles we solved. Okay, in this book there were many puzzles, and most of the time whenever we were traveling in the metro, okay, in the Delhi metro, then we would solve these puzzles. Okay, so anyway, you can check it out. It's not necessary. It's not necessary for the GATE exam. You can ignore, or maybe after the GATE exam you can check it out. Okay, this book contains many mathematical puzzles. Okay, these puzzles you can solve not easily. These puzzles you can solve if your mathematical logic is good. Propositional logic, first order logic. If your logic knowledge is good, then you can solve these puzzles. Okay, let's see some of these puzzles. Let's see some of them. So let's see this one. Okay, so let's see. Now, so he basically, in his book, he has 2 type of people. So there is an island. Now what he is saying? So he is saying that there is an island. Okay. Now on this island there are two type of people. On this island there are only two type of people. One are knights and one are knaves. Only two type of people. These people, they always tell truth. They always say truth. Okay. And these people, they always lie. Is this clear? So these people will always say truth and these people will always lie. On this island, there are only two type of people. Either a person is knight or a person is knave. Only two type of people are there. Knaves, they will always lie, and knights, they will always say the truth. Okay. This type of island is there. Now the question is saying, see the question. Now you meet two people. You encounter two people. Okay. You encounter two people, A, B. On this island, there is an island. Okay. Now, what are A, B? You need to find it. What are A, B? Are they knaves, knight? What are they? A says B is knight, and B says two of us are opposite types. Okay, so let's solve this question. What the question is saying? See, you go to this island and you meet two people. This is you. Okay, on this island, there are two people, A, B. This is that island. Okay, now you need to find whether they are knight or knave. This A is knight or A is knave, B is knight or knave. So this is what you have to find. Now what they are saying, this A is saying that B is knight. And this B is saying that both are different. This A is saying that B is knight, and B is saying that both of us are different. Both of us are different means A, B are different. Okay. Now you need to find which of them is knight, which of them is knave. Okay, let's see how to solve this question. This is actually very simple. This is a puzzle, right? So this is interesting and this is very simple also. Now what you need to do, see, first you consider these statements. Let's assume statement P. Let me assume that statement P. Let me create one statement P, and statement P is, let's assume A is knight. Okay, so this is propositional variable A is knight. And let's assume statement Q is B is knight. Okay, is this clear? So statement P is A is knight and statement Q is B is knight. So let's assume. Now tell me what A is saying. Tell me what A is saying. What A is saying, please tell me. A is saying P is true. Right? A is saying P is true. Because A is saying Q is true. Sorry. A is saying Q. Because A is saying that B is knight. Okay, so A is saying B is knight. Means A is saying Q. B is saying what? Can anyone tell me B is saying what? B is saying what? B is saying that exclusive or B is saying P exclusive or Q? Yes or no? B is saying P exclusive or is true. See, A is saying this is true. B is saying this is true, right? Is this clear? A is saying Q is true and B is saying both of us are different, means this is true. Okay. Now how to solve? Now you can assume A is knight. There are two cases, right? Yes or no? Assume A is knight. Only two cases. Now you are thinking, this is you. You are very smart. Okay. Now you are thinking. So what to do? How to find out? Then you can take your copy pen. Okay. You can take your copy pen, and what you can do, you can create two cases. You know that only two cases are possible. Either A will be knight or A will be knave. See, you know that only two cases are possible. Either A will be knight or A will be knave. Either this case is possible or this case is possible. Do you agree with me? Either this A will be knight or this A will be knave. Either this case will be possible or this case will be possible. Let's check. If A is knight, then it means which statement is true? See, if A is knight, then he is speaking truth. If A is knight, then A is speaking truth, correct? A is speaking truth. You are assuming A is knight, okay? Case 1, A is knight. You are assuming A is knight, it means P is true, right? You are assuming A is knight, it means P is true. It means this P is true. See, this P is true. Is this clear? Please tell me. You are assuming A is knight. This is what you are assuming. Case 1. You are assuming that, let's assume A is knight. You are assuming, it means P is true. It means P is true. Because this is what you are assuming, that A is knight. So it means P is true. And because A is knight, so A is speaking the truth. So it automatically means Q is also true. A is speaking the truth, so it may automatically means Q is also true. Because A is speaking the truth. A is speaking the truth. It means this is also true. Okay. So it simply means P is true, Q is true. It means both are knight. So in this case, you got that both knight. Okay. So you can say both knight. Okay. Case 1. You take your copy pen. So case 1. Case 1, I am assuming that, assume A is knight. Okay. If you assume A is knight, it means P is true. It means P is true. A is knight. A is knight. So it means this P is true. And because A is knight, so it means A tells truth. So what he is saying, that is also true. A tells truth. So it automatically means that Q is also true. Q is also true. Q is also true means B is also knight. If B is knight, then he is telling truth. If B is knight, then he is telling truth. But what he is saying? But what he is saying? Tell me. But what he is saying? See, B is knight, so B is telling truth. But what he is saying? But B is saying we are different. But B is saying we are different. But B is saying we are different. Both A, B different. Now tell me. So that is the contradiction. So there is a contradiction in this case. Immediately what you can say? This case is wrong. Immediately you can say that this case is wrong. So, okay, so immediately I can say that there is a contradiction. There is a contradiction. So I can discard this case 1. So I can say, so case 1 is never possible. So case 1 is not possible. Okay, case 1 is definitely not possible. Let's see the case 2. Now let's see case 2. Let's check the case 2. In case 2, what will happen? You are assuming A knave. If I assume A knave, then it means P is false. So he is lying. So he is a liar. So this A, he is a liar. So he will speak the false. So it means, it automatically means that Q is also false. Okay. If Q is false, that means B is also knave. If B is knave, he is also liar. Okay. If he is a liar, what he is saying, that is a false. So it means, so what he is saying, that is a false. So both same. So both AB must be same. And there is no problem. Here there is no contradiction. Okay, here there is no contradiction, right? Isn't it? Here there is no contradiction. Both are same. There is no contradiction. Both are same. A knave, B knave, both are. There is no contradiction here. So here there is no contradiction. So here there is no contradiction. So finally we can say that yes, both are knave. So your final answer will be that both are knave. So what is the final answer? Both knave. Both A, B are knave. Is this clear? Anyone has any doubt in this? See, this is a simple puzzle type of question. This type of questions are there in the GATE exam also. Okay. If you are thinking, sir, this type of questions, do they come in the GATE exam? Yes. Already in the GATE exam, this type of questions are already there. Okay. Tell me, did you understand this? This question? Let me know. Anyone has any doubt in this? Simple puzzle type question. Very simple puzzle type question. If you get a contradiction in some case, then that case you discard. Okay. If you get a contradiction, if you get some contradiction in some case, then that case you discard. Okay. So here in this question, you can easily see that if you assume A is night, see, if you assume that A is night, then there is a contradiction. If you are assuming A is night, because if you assume A is night, then P will be true. If you are assuming that A is night, then P will be true. If P is true, and because he is a knight, so he is telling the truth. He is telling the truth. It means Q is true. Q is true means B is knight. So B is also telling the truth. Okay. So this B is also telling the truth. So you can easily see that if B is telling the truth, then there is a contradiction. B is telling the truth. So then there is a contradiction because B is saying that we are different. B is saying that we are different. But that is the contradiction. Okay, so easily you can do. Let's see one more question. Just last question, please tell me a similar question, but now this is what this is saying. Now A comma B. Now you have to find what are A comma B. Knights always tell the truth. Knaves always lie. You meet two people A comma B. A is saying that either I am knave or B is knight. Either I am knave or B is knight. You have to find what are A comma B. So what is happening? Now you meet A comma B. Again you meet, this is you. Again you meet two people, A comma B. What these people are saying? This A is saying that either I am knave or B is knight. Okay. So tell me what this A is saying. Basically, if you assume that, let's assume that P means A knight and assume Q means B knight. So these are the two propositions. P means A knight, B means Q means B knight. Let's assume. Okay. So these two propositions you can assume. So tell me what A is saying basically. Basically, A is saying that I am knave or B is knight. I am knave or B is knight. So he is basically saying P bar or Q. He is basically saying P bar or Q. Okay. Suraj is asking, should we consider it inclusive or? Suraj, did you watch the lecture? I told you that if you have this statement, either P or Q, that is P or Q. And if you have this statement, either P or Q, but not both, this is exclusive or. Okay. Now let's see. So here you can see that the statement is, the A is saying that either I am knave or B is knight, means P bar or Q. This is what A is saying. So remember, A is saying P bar or Q. Again, the same thing you will do. You will make two cases, right? Correct? Just make two cases. What is the case one? Assume A is knight. Case one, you can create case one. You can assume A knight. If you assume A knight, then basically what is true? Tell me quickly. From this, what information can you give? If you assume A knight, what can you give? If you assume A knight, then it means P true. And what he is saying, that is also true. What he is saying, that is also true. So from these two, what can you say about Q? From these two, what can you say about Q? From these two, what can you say about Q? Q must be true. Q must be true. Very good. Because P is true, so this is false. False or Q is true, so Q must be true. Very simple. So in this case, we got P true, Q true. Let's see case 2. Let's see the case 2. What is case 2? You assume A knave. You assume that A is knave. If you assume A knave, then what will happen? Then it means P is false. You are assuming A knave, it means P is false. So what he is saying, that is also false. He is a liar. A is a liar. So what he is saying, that is also false. So what he is saying, that is also false. But there is a contradiction. Can it happen? There is a contradiction. This cannot have. This is a contradiction. This is a contradiction. Because if P is false, then this is true. True or anything is true. So there is a contradiction. So your final answer will be what? That both are night. Okay, so for this question, the final answer is both are night. This is the final answer, that both are night. Okay. Anyone has any doubt in this? Let me know. In any question. Sukhjit is saying that, can we approach the question as P implies Q? Yeah, you can do that. Just don't make it wrong. Okay. You can solve any question by many methods. Sukhjit, same question you can solve by many different ways. Okay. So if you have a different way, if you have a different method in your mind, you can do that. Just make sure that you are not wrong. Your method is not wrong. That is the only thing you need to make sure. Satyam is saying, can we solve it with truth table? Satyam, yes, you can solve using truth table, but that is worthless. Okay. It will take so much time. It is not worth your time. In the GATE exam, you cannot use this. Okay. If you are using truth table, someone else is using some efficient method, then you can see you will be at the disadvantage. Okay. So don't use truth table. Anyone has any doubt? Please tell me. In this session, some good questions we have seen. These are standard questions. Some different type of questions we have seen. See, almost 5-6 questions I have taken, but all have different types. Did you notice? 5 or 6 questions, but every question has a different template. Every question is of, I can say, is of different category. Only 5 questions or 6 questions I have taken, but each question has a different category. Please tell me, did you understand? Let me know. All these are standard questions, some good quality questions. I hope you understood. Please tell me if you have any doubt. Did you understand this night knave question? Let me know one by one. This night knave, this puzzle type of questions, can you solve? Very simple. You just need to create 2 cases. Okay. Case 1, case 2. Very simple. Case 1, case 2. You just need to create cases. Case 1, case 2, case 1, case 2. You only need to create cases. In this night knave puzzle type of questions you can solve, right? Okay, so many other questions we have done. So I think this session was, I find it, these questions, I think they were good. Okay, I hope you find the same. Manome Joshi is saying that I was thinking propositional logic is easy. Today my illusion was shattered. Manome, did you understand these questions? The solutions, everything, did you understand? Please let me know. In this session, every question that we have done, did you crystal clearly understand? You are understanding the questions, the solutions you are understanding, the logic you are understanding. So that is what matters. I hope that is clear.